Yeah, thanks very much for the introduction. It's great to be here and talk a little bit about the applied research that we do at Rasa, specifically on language understanding and on dialogue. So what is Rasa? We build open source tools for developers to build conversational systems. So that includes, like I said, language understanding and dialogue, and it's open source. So we work with large enterprises who then buy extra products on top of that to help them as they work on these projects with a whole team. But the things that the developer use are all free and open source. And so the product we're best known for was Rasa NLU. We launched that last December, and it's now got an amazing community behind it. Lots of people using it. I think it was really the right product at the right time. It's actually, in many ways, incredibly simple. And I want to talk about the things that we've been doing since then and the things that are happening next. So like I said, there's startups using it, and there's bot building and voice platforms that use it as their in-house NLU. We also work closely with university research groups on a number of these topics, but primarily we work with large corporates like UBS and ERGO and Helvetia in primarily financial services, so insurance and banking, also in utilities, in aerospace and automotive a little bit as well. So like I said, we really want to differentiate by being the people who advance the state of the art, look at the white space between what's happening on archive and what's happening, what developers are using right now. And so we're very much like an applied AI research company. And so we work very closely with academia. There were a couple of papers published this summer using Rasa NLU. Then, we also supervise master's students. We do joint research projects. So, we're very much convinced that there are really important problems to solve in this space, and they haven't been solved yet. And to really enable the next generation of, interesting conversational software, we need to invent a lot of new things. So I think we've come very far, but, we have by no means solved it. Okay, so NLU in one sense is really easy. So in the sense of chatbots, right? If somebody says, show me a Mexican restaurant near Liverpool Street, right? Detecting that that's a restaurant search and pulling out those entities, that's actually quite straightforward. That's what Rasa NLU does for you. There are a number of different products you can use for that. On the other hand, NLU is really hard, because if somebody says, no, I don't want Mexican food, right? That's actually pretty trivial to note that that's a negation. So you look for the word not, and you look at what comes after, and that's actually state of the art. So people have trained like deep neural nets for a negation, and then when you poke at them and look at what they really do, they look for the word not, and then they look for what comes after. So that's really kind of as good as it gets. And then if you have a trickier kind of semantic negation, right? Like, I would rather go hungry than eat Mexican food, right? That's obviously a negation, but that's really tricky to catch. So some problems, like technical problems in NLU, are really hard. And then in the general case, NLU is impossible. So it's actually not even a well-posed problem, I would assert. So you can only define understanding language with respect to a downstream task that you care about. So predicting a class label, as we discussed, like an intent or something like that. There's no universal truth of what does this sentence mean? Do these two sentences mean the same thing? It's always contextual, right? So there's really no kind of global answer. And there's a lot of really difficult things that you want to capture in meaning that are really not captured at the moment. So if there's some great work by Andrew Kaler, who's at San Diego or something like that, and he shows these two great examples that you have one sentence which is the company fired the manager who they hired in 2002, and then the other one is the company fired the manager who was embezzling money. And these are almost the same sentence. But in the second example, of course, there's an implied inference on the part of the hearer that they're going to assume that it's because they were embezzling money that they were fired, right? And that includes a huge amount of common sense about the world and knowledge of how people interact and what these things really mean. And that's totally uncharted territory right now. Anyway, I want to talk about how even if you had great NLU, it's still not enough. So you start with like question-answer pairs. This is how chatbots start and voice assistants start. And we've taken a customer service use case for financial. So in this case, it's a bank. And the person can ask about mortgages or about savings accounts. And in the ideal case, the person asks a well-qualified question like, which savings account has a better interest rate? What you're more likely to see is, there's a conversation that happens beforehand. They're talking about, either savings accounts or about mortgages, and then they just say which has a better interest rate, and they don't help you, right? So obviously you need this context to understand how to answer that question. And even which one is better depends a lot on whether you're talking about savings or mortgages, because they're kind of opposite. Okay, so there's kind of two extremes for how you handle context in dialogue. So on the one extreme, you have a bunch of hand-coded rules. On the other hand, you have just a sequence model. This is really great work from Oriel Vinyals and co. And there's nothing hand-coded in there. Everything is learned from text. So if these amazing things come out, like what do you think about Messi? He's a great player. There's no kind of look up on Wikipedia or anything like that. The hand-based approach really doesn't scale. And then in the middle, you have interesting work, and that's obviously where we like to sit as well. So what do people do currently? I mean, you take it very literally and you implement a state machine. This is what everybody does. So you say, okay, I'm in some initial state. The person asks about a mortgage, or they asked about savings, and you define some rules for how people can go between those states. And then when the person asks a question like which has a better interest rate, you condition on which state you're currently in, right? And the thing about that is it doesn't scale, because every conversation will add another edge case to this graph, and you'll have to add more nested logic, and then you look through the conversations and you realize that it wasn't just happy paths, right? Because the person might say, oh, I'll pick option 3 when you only give them 2 options, and then you have to resolve that. Or they ask for something nonsensical, or they ask a further follow-up question like, why are those interest rates so different? Or what's the catch? Why is that one so cheap? Etc. So you have kind of infinite bifurcating conversations, and you can't pick up on common patterns because you're just kind of hand-coding all of these rules. Now, this is not a new insight. People have thought about this for a long time. Here, I even had an example with a graph. So yeah, here they said option 3. And so every conversation that you actually see in the wild is an edge case of an edge case of an edge case. So there's a lot of interesting work on dialogue research. Okay, we already had this example. This is really great work. There's a couple of decades of work on this topic, right? So this is not like a new insight that these state machines don't scale and you need to do more interesting things. And so primarily what people do is they use reinforcement learning, and that has some drawbacks, right? So I really like this quote that if you say this is a reinforcement learning problem, you should say it with the same excitement as this is NP hard. Reinforcement learning is incredibly flexible. All you have to say is this is the reward, right? And then at the end, it learns to do the right thing. But then, of course, you have a lot of decisions to make, and you have to kind of assign credit to which decisions helped you and which ones hurt you, and you have a big decision space. So it tends to be very data hungry. And so you either have to train your reinforcement learning against real users and have thousands or tens of thousands of dialogues, which is kind of tricky. And even then, humans are not reliable evaluators, right? So I was speaking to Oliver Lemon, who was, they came third in the Alexa Prize competition. And the systems were assessed by having users talk to the system, and then at the end they were given a rating, right? And they were going through some of the ratings, and some of them were like a single question with a totally nonsensical response, and the person gave them 5 stars. And some were like some of their best dialogues, and they got 1 or 2 stars or something like that. So it's really unreliable to use human evaluators. And so it's not as simple as, oh, we'll just stick it on Amazon MTurk. It's not that trivial. And so what you tend to do is you tend to train against a simulated user. So then it restricts you to problems where you can exactly specify what it is this person wants, and write that down as a function, right? And did the dialogue at the end do the right thing, or did it not do the right thing? Okay, so there's a lot of white space there between, reinforcement learning on a well-scoped, well-defined, well-posed problem where you can actually make some progress, and then an actual product that developers can use to actually build a system, right? So we wanted to build something where, yes, you use machine learning. No, you don't have to build a state machine, but you can also use some of this domain expertise that you already have. You already have a best guess of what kind of conversations you want to see. And then, of course, we really focused on enterprise, right? So when we looked at the companies that we work with and who use our tools, it's very, very rare that people have good training data. I mean, they'll have data, but it's basically useless most of the time. And they're usually not aware of this. So companies think they have great data, but actually you can't do anything with it. The second one is, of course, it has to run in, in a real environment, and you want to interact with the outside world, right? So you want to be able to kind of call APIs, look in a CRM, look at some real information from within your company, pull it into that, include for context and things like that. And then ultimately, sometimes you just need some hand-coded rules in there, right? So if you have an action which requires authentication, you can't get away with just kind of predicting with non-zero probability to do an action that is forbidden, right? You can't just rely on that. So we decided to take a different approach. So get rid of the state machine for sure. I mean, that's definitely step one. That will save you thousands of hours of frustration. And use the Rasa stack. So there's Rasa NLU and there's Rasa Core. This is in early access at the moment, but it's almost ready for prime time in terms of documentation and things like that. And so we're going to open source that very soon. And so you can think of it like Rasa NLU tells you what did the person just say, and then Rasa Core says what's the next thing I should do. So as a developer, you define a list of possible things, possible actions that your system can take, and then you train a model which predicts, conditioned on the history of the conversation, what is the next thing I should do. And those actions can be simple things like just saying something to the user, or they can be more complicated things like calling an API or looking in a database or whatever, and they can return values back to the system to help it decide again, so you can take in information from the outside world to help, coordinate the dialogue. And because it's open source, you can run it on-prem, you can run it on device, you can run it behind your firewall, you can integrate with your legacy systems, etc. So we decided not to use reinforcement learning, but what we like to think of as interactive learning. So you directly talk to the system and teach it as you talk to it. So you boot up your bot and you start with some kind of simple happy path conversations that you feed in as training data. And then you talk to your system and it asks you for feedback. So this is what I'd like to do next. Is that right? Because the thing is that in the middle of a conversation, it's totally trivial to know whether your system did the right thing or the wrong thing, right? I mean, a 4-year-old can tell if Google Assistant gave you a good response or not, right? But if you've got this state machine with, really typically, a couple dozen states and a few thousand rules, realistically, we've actually done this. It's really horrible. And then you get to an edge case and you go, okay, what do I do now, right? You go and you write another rule that clashes with your old rules or breaks something else, and you spend thousands of hours kind of, thinking through all the things that went wrong and trying to debug it, right? So what if just knowing what it should have done was enough to correct the system? So that's what we do. The bot asks, was this the right thing? And then if you say no, then it says, okay, what was the correct next action? So it dumps out things that it could have done and the probabilities that it's assigned to those things. And then you train it, right? And because you're giving not just a reinforcement learning signal at the end of an episode, at the end of a dialogue, was this good or was this bad, but you're step-by-step correcting it, you're giving a lot of really direct feedback, and you train the model very quickly. So in practice, what we see is, a couple of dozen dialogues get you very, very far. So that's very much coming up soon. So if you want early access, you can email me, but to be honest, it's getting open source so soon it might not even be worth it. So keep an eye out. We're hiring, obviously, actually only in machine learning. So we already have a nice-sized team of very clever people. And if you want to work on these interesting problems, in an very applied AI research environment, you want to ship code, you want to work with our huge community of tens of thousands of developers and support them and help them build things and implement things in large enterprises, then do reach out. And thanks for your attention.